This lesson will be on L'Hopital's rule. Guillaume de L'Hopital was a French mathematician, and he came up with a very interesting method to find limits whenever you have a value being approached that if you use direct substitution would give you indeterminate forms such as 0 over 0, infinity over infinity, or something like that. So let's say you have a rational function f of x over g of x, and when you plug in the value of x as it was approaching a particular number, f of x will become 0 and g of x will become 0. So what he came up with, he discovered that he could find the derivative of the numerator function and the derivative of the denominator function, and then do the substitution as x approaches that given number, and then he would find the limit in that sense. Okay? Make sure you understand that it's L'Hopital, not the hospital, all right? So it is not a hospital for little alien forms that are 0 over 0 or infinity over infinity going to get cured for indeterminate pain, okay? So we'll see a few examples, and hopefully by the end of the video, you'll understand. So the first example we're going to do is one where we can try factoring to eliminate an indeterminate form. And then after we do the factoring method, then we can try doing it with L'Hopital's. So let's begin. You can take the limit as x approaches 5 of that quantity 3x squared minus 11x minus 20, but I think you have enough practice to come up with the factoring for a quadratic function. Take a few seconds to see if you can figure it out. Okay, so I'm hoping that you got x minus 5 times 3x plus 4. Then the bottom you have x cubed minus 125. That's called a difference of two cubes. So that one can also be factored. Take a few seconds to see if you can do it on your own. So on that one, you should have gotten x minus 5 times x squared plus 5x plus 25. So you might remember that we did something called removable discontinuities in the past. So this is what happens in this case. So we have the limit as x approaches 5 of, in this case, x minus 5 at the top cancels with x minus 5 at the bottom. So those are gone, okay? And what's left is 3x plus 4 in the numerator and x squared plus 5x plus 25 in the denominator. Now let's do the substitution. So this is the limit as x approaches 5 of 3 times 5 plus 4. Now we can do the direct substitution because we got rid of the removable discontinuity. At the bottom, you're going to get 5 squared plus 5 times 5 plus 25. So at the top, we get 3 times 5 is 15 plus 4 is 19. And the bottom, we get 5 squared is 25, 5 times 5 is 25, that's 50, and 25 more is 75. Well, 19 over 75, and this fraction is composed of relatively prime numbers, so you cannot reduce it. So that's it. The limit for this particular problem, as x approaches 5, Even though it's a rational function, we can still figure it out. It's 19 over 75. Okay. All right, let's see if we can do a different approach. Let's apply what we call L'Hopital's rule. So this is how it works. We're going to say the limit as x approaches 5. Remember that you cannot just plug in because you will get 0 in the numerator and 0 in the denominator. But we're going to do this. We're going to take the derivative with respect to x of 3x squared minus 11x minus 20 over the derivative with respect to x of x cubed minus 125. Okay? So this is going to be the limit as x approaches 5. And let's take the derivative for the numerator is using the power rule. 2 times 3, we get 6x minus 11. And then at the bottom we get 3x squared, again power rule. And then the minus 125, well that's a constant, so it goes to 0. Now we just do direct substitution. As x approaches 5, we get 6 times 5 minus 11 over 3 times 5 squared. 6 times 5 is 30. 30 minus 11 is 19. And then 5 squared is 25 times 3 is 75. And there we have it. Exactly the same thing. So as you can see, L'Hopital's rule is very powerful. Let's try another example. Again, if you need to just go back and review the video, pause the video, or do whatever you need to do to make sure you understand every single step. Okay, example 2. This one we have a limit as x approaches 0 of e to the 2x minus 1 over x. Now, if you do direct substitution, in this case, what's going to happen is that you're going to get 0 at the top, 0 at the bottom. Okay? So let me just make that notation. That's too thick, sorry about that. With direct substitution, look what happens. You will get e to the 2 times 0 minus 1 over 0. Okay, 2 to the 0 power, I'm sorry, 2 times 0 is 0, and e to the 0 power is 1. So this is your indeterminate form. So therefore, we cannot follow that approach. So what about using L'Hopital's rule? So we're going to say the limit as x approaches 0, and remember it's always going to be the derivative of the numerator over the derivative of the denominator. Notice it's the derivative with respect to x. So we're just doing explicit differentiation with respect to x. Okay? So what is this going to be? The limit as x approaches 0, And remember that when you have e to the x, the derivative is e to the x. By using the chain rule, the derivative of e to the 2x is going to be e to the 2x times the derivative of the exponent, which is going to be times 2. So this will give you, of course, remember the 1 is a constant, so that goes to 0. So the derivative then becomes e to the 2x times 2, and of course minus 0 because the derivative of 1 is 0. Over the bottom, the derivative of x is just 1. Now we can do direct substitution. When x approaches 0, this approaches e to the 2 times 0 times 2 over 1. 2 times 0 is 0, and e to the 0 power is 1. So this becomes 1 times 2 over 1. And 1 times 2 is 2. 2 divided by 1 is 2. There is the limit. Again, using L'Hopital's rule. Okay. Next example. Now let's try one where you have an indeterminate form, infinity over infinity. So here you have the limit as x approaches infinity of natural log of x over x. Again, this would give you the indeterminate form infinity over infinity if you try direct substitution. So we're not going to do that. That's not going to work. So let's apply L'Hopital's rule. So we're going to get the following. We're going to have the limit as x approaches infinity of the derivative of the numerator over the derivative of the denominator. By now you should know that the derivative of natural log of x is 1 over x. And of course the derivative of x is just 1. Okay? Now 1 over x over 1 is just 1 over x. So this is the same thing as saying the limit as x approaches infinity of 1 over x. Now we can substitute infinity there, so now we get 1 over infinity. Also by now you should know that 1 divided by a very, very, very large number is going to approach 0. So if the number goes to infinity, then 1 divided by infinity is always going to be 0. Okay. There's the answer for that one. Okay, let's try another example. The next one is when you have to apply L'Hopital's rule more than once. Okay, so this one is evaluating the limit as x approaches negative infinity of x squared over e to the negative x. So in this case, we have to apply the rule more than once, and you'll see why in a minute. Direct substitution will not work because you will get infinity over infinity. Okay? So, L'Hopital's rule. First, we're going to get the limit as x approaches negative infinity of the derivative with respect to x of x squared divided by the derivative with respect to x of e to the negative x. Okay. So this gives you the limit as x approaches negative infinity. Well, what is the derivative of x squared? That's just 2x. Divided by the derivative of e to the negative x. Well, you have to use the chain rule. It's e to the x, but with a negative, so it's going to be e to the negative x. That's the derivative of negative x, which is negative 1. So you're going to get negative e to the negative x. Right? So by direct substitution, this would yield the indeterminate form infinity, actually negative infinity over negative infinity. All right? So then that's not good. So what do? You apply L'Hopital's rule again. Therefore, apply the rule again. So there's going to be the limit as x approaches negative infinity of the derivative with respect to x of 2x over the derivative with respect to x of negative e to the negative x. Negative e to negative x. Which gives you the limit as x approaches negative infinity, where the derivative of 2x is just 2. And the derivative of negative e to the negative x, after you apply the chain rule, is e to the negative x. So if you substitute negative infinity where x is, you will get e to the positive infinity, which is a huge number. So now you have 2 divided by a huge number, right? So this is 2 over e to the negative infinity, which is positive infinity. And e to the positive infinity is just a huge number, and 2 divided by a huge number is just 0. There's the answer, 0. And I just noticed that it started raining. I don't know if it's raining where you are. I guess you don't have to go outside anyway. Okay, so we'll do one more example. I think that'll help you. It'll be enough for you to understand the assignment and the quiz. I think you'll be okay after this example. Let's try an indeterminate form 0 times infinity. See how that works. So this is when you have the limit as x approaches infinity of e to the negative x times radical x. So before you get confused, even though it's a product, and L'Hopital's rule is used when you have a quotient, like a function divided by another function, well, you're going to do the same thing here. You apply the rule by rewriting the problem, okay? So we're going to rewrite the problem. So this is going to be the same thing as the limit as x approaches infinity of, instead of e to the negative x being at the top, you're going to write radical x over e to the positive x. Remember that you can change an expression. If it has a negative exponent, you can bring it to the bottom and make it a positive exponent. Now we can apply L'Hopital's rule. So now we're going to have the limit as x approaches positive infinity of the derivative with respect to x of radical x over the derivative with respect to x of e to the x. Right? Let me rewrite that. This is the limit as x approaches infinity. Well, the radical x, in case you forgot, can be rewritten as x to the 1/2 power. That way it is easier to differentiate, of course, over the derivative with respect to x of e to the x. So this gives you the limit as x approaches infinity of what is the derivative of x to the 1/2 power is 1/2 times x to the negative 1/2 power. Play with that a little bit and you'll see that that's the answer using the chain rule and the power rule there. Actually, just the power rule. Divided by what is the derivative of e to the x? The derivative of e to the x is e to the x. We can rewrite that to simplify it just a little bit. This is the limit as x approaches infinity, and 1/2 times x to the negative 1/2 becomes 1 over 2 radical x over, and then e to the x. Since you have a fraction in the numerator, you can write the bottom one also as a fraction. And if you do that, then what you can now do is multiply the inner by the outer. You can say, what if I take this 2 and this 2, and that makes it a lot simpler now, right? So this becomes the limit as x approaches infinity. 1 times 1 is 1 over 2 radical x times e to the x. But if you substitute infinity where the x is, you get 2 times the square root of infinity, which is a huge number, times e to the infinity, which is also a huge number, and 1 divided by a very large number, or 1 divided by infinity, is 0. And that is the answer. All right. So I think that'll give you a better idea of how to use L'Hopital's rule to find limits when you have indeterminate forms. Good luck.